some reverse engineering, but that was yesterday. Today's today. So working through the web fundamentals course, I have apparently at some point in time done the how the web works portion of it, and then I have gone through all of the actual exploitation parts. So like the tests, that's kind of what I've done. And then in Burp Suite, we've done the basics, and then nothing inside of Intro to Webpacking. So none of the actual teaching part. 57% of the way through, but we're going to start at walking an application, and I think that I'm already connected to the VPN. Get the machine started. Cool. Hooray. Cool. In this room, you will learn how to manually review a web application for security issues using only the inbuilt tools in your browser. More often than not, automated security tools and scripts will miss many potential vulnerabilities and useful information. I've heard that a lot. I hear a lot of people saying that something like, what is it? Is it Burp Suite? Is it called Automate or Collaborator? Something like that. Whatever like runs the automatic script detection, it'll actually miss a lot of things. So manual enumeration tends to be better if you're not searching out like low-hanging fruit, right? Because everybody can throw a scan, but not everyone can manually exploit an application. So here's a short breakdown of the inbuilt browser tools you will use throughout this room. View source. Use your browser to view human readable resources, code of a website, inspector, inside of Burp Suite, debugger. Oh, okay. So inspect, view source, and then they're talking about the debugger here, and then the network tab. Of course, when we load, it shows us where our requests are going. Come on, baby. Or what requests are being made. To start the virtual machine, wait 2 minutes, visit the following URL, and we'll move on. So we can now access it. We're at Acme IT support, and we'll move along. As a pen tester, your role when reviewing a website or web application is to discover features that could potentially be vulnerable and attempt to exploit them to assess whether or not they are. These features are usually parts of the website that require some interactivity with the user. Finding interactive portions of the website can be as easy as spotting a login form to manually reviewing. Be as easy as spotting a login form to manually reviewing the website. Attempt to exploit the site features. Website JavaScript. An excellent place to start is just with your browser, exploring the website, noting down the individual pages, areas, features with a summary for each. As an example, site review the AFMC or Acme IT support website. Like something like this. So showing us they can see the home page, news with an ID. Some articles seem to be blocked and reserved for premium customers only. Looks kind of juicy. Contacts. This page contains a form for customers to contact the company. Contact the company. It contains name, email, message, input fields, and send button. Customers/customers. This link redirects to customers login. Customers login. Pages login with the form of username and password. The sign up page. Reset password page. A lot of these could very well be vulnerable. Reset, login, articles, contact. Maybe they're all vulnerable. A ticket to IT. This page forms text box when entering IT issues, and a file upload option to create an IT support. So maybe file upload. This page allows the user to edit their username, email, and password account page. Okay. Like maybe here we could edit somebody else's account page. Maybe here we could execute code. Let's see. This page is the human readable format. Oh, viewing the page source. Viewing the page source is the human readable code returned to our browser client with a web server each time we make a request. The return code is made up of HTML, CSS, and JavaScript. It's what tells the browser what content to display, how to show it, and adds an element of interactivity with JavaScript. For our purposes, viewing the page source can help us discover more information about the application. How do I view the page source? You view the page source by right-clicking and hitting View Page Source, or appending View Source, prepending View Source to the URL or IP in the browser. Let's view some page source. Okay, cool. Let's go here and we'll view it. Check it out. This page is temporary while we work at the new page, new home beta. Oh man. So they're showing us that they're trying to hide information inside of comments. The page will notice some code. So comments are messages left by the website developer. Yep. View the web page in the comments to get the first flag, which is here. Tryhackme HTML. What does that say? Comments are dangerous. Fair. Links to different pages in HTML are written in anchor tags. And the link you'll redirect it to is stored in the href. If you view further down the page source, there's a hidden link to the page starting with SECR. View this link to get another flag. You obviously won't get a flag in a real world situation, but you may discover some private areas used by businesses. Okay, so let's get rid of that page. SEC secret.page. Cool. Not a secret anymore. External files such as CSS, JavaScript, and images can be included using HTML code. In this example, you'll notice that these files are all stored in the same directory. If you view this directory in your web browser, there's a configuration error. What should be displayed in either a blank page or a 403 forbidden page, which 403s can be bypassed sometimes. So, because it's not like 401 where you aren't authorized. It's like you just don't have access to it. You don't have like credentials or something. I can't remember the actual term, but I know that it's possible to bypass 403 pages. With an error stating that you don't have access to the directory, instead the directory listing feature has been enabled, which in fact lists every file in the directory. Sometimes this is an issue, and all the files in the directory are safe to be viewed by the public. But in some instances, backup files, source code, and other confidential information could be stored here. In this instance, we get a flag in the flag.txt file. What is the directory listing flag? What was the question? Many websites these days aren't made from scratch and use what's called framework. Framework is a collection of pre-made code that easily allows a developer to include common features that a website would require, such as blogs, user management, form processing, and much more, saving the developer hours and days of development. Viewing the page source can often give us clues into whether a framework is in use, and if so, which framework, even what version. Knowing that framework and version can be powerful. Can be a powerful find, as there may be public vulnerabilities in the framework, and the website may not be able to using the most up-to-date version. At the bottom of the page, you'll find a comment with the framework and version in use, and a link to the framework's website. Viewing the framework's website, you'll see that there is a website. that our website is, in fact, out of date. Read the update notice and use the information to find that you find to discover another flag. What is the directory listing flag? What? Yikes. Let's start that over. Cool. Oh. Oh, so assets. Okay. Gotcha. And then what was the question? Oh, what's a flag? Cool. And then we're looking for framework, which we've pulled up in one of these. Not that, not that. Quickly builds fully functional websites with features such as new portals, contact form, current version 1.3. Our version 1.2. You can log in with username admin and password admin. Make sure to change that password. Well, I mean, I don't know if that's the case, but I don't know if that's what they were asking for. Documentation. I thought maybe it changed. Oh, we've added a backup facility in the administration portal. Was it admin? Oh my. Tryhackme change default creds. Right, so common misconfigurations are... Oh, your answer is incorrect. Change default credentials. Sorry, what? Now we've added contact form, blah, blah, blah. We've added a backup facility. Oh. Him.zip. Well, there's another one. Not sure what it's for, but we'll find out in a second. And then it was what? Temp.zip. Page not found. It's root. Give me the file. Well, keep your software updated. Where the hell did that other flag go to then? What did that go to? What is its purpose? Was it something else and I just like missed it, or is it something later on? Not sure. Get rid of all of it for now. Admin. Oh, we'll just leave that up. Okay. Developer tools. Every modern browser includes developer tools. This is a toolkit used to aid web devs in debugging web applications and give you a peek under the hood of a website to see what is going on. As a pen tester, we can leverage these tools to provide us with a much better understanding of the web application. We're specifically focusing on 3 features of the development toolkit: inspector, debugger, and network. Accessing dev tools. Why is it? It wants us to view. The way to access developer tools is different for every browser. If you're not sure how to access it, click the view site button at the top right of the page. Oh, it's okay. Well, that's go away. The way to access developer tools is different for every browser. If you're not sure how to access it, click the view website. Okay, got it. Inspector. The page source doesn't always represent what's shown on our web page. This is because CSS, JavaScript, and user interaction can change the content and style of the page, which means we need a way to view what's being displayed in the web browser at the exact time. Element Inspector assists us with this by providing us with a live representation of what is currently on the website, as well as viewing this live view. We can also edit and interact the page elements, which is helpful for web developers to debug issues. On the Acme IT support website, click on the news section where you'll see 3 articles. The first 2 articles are readable, but the third has been blocked with a floating notice above the content stating that you have to be a premium customer to view the article. These floating boxes blocking the page contents are often referred to as paywalls, as they put up a metaphorical wall in front of the content you see until you pay. Three tips to keeping your printer working. Gotcha. Stupid. News. 3 tips to keeping your printer working. Cool, let's inspect it and just get it out of here. Yeah, is it this whole... I think it's just this. Let's just delete the node. Get out of here. Oh my, Tryhackme, not so hidden. Now where is it? Give me the freaking flag. Oh, it's an image. Okay. Well, that works. Let's Tryhackme. Yikes. Not so hidden. I guess I could have read the rest of it. Look at the div tab element in the class, premium, blah, 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 click on it. Yeah. Get out of here. I don't know. I just deleted the whole thing. What did they want us to do? Oh, okay. They wanted us to just edit it out of the way. I just removed it in total, but that's okay. And next, this panel, Developer Tools Debugger. This panel on the Developer Tools is intended for debugging JavaScript, and again is an excellent feature for web developers waiting to work out why something might not be working. But as a penetration tester, it gives us the option of digging deep into the JavaScript code. In Firefox and Safari, this feature is called Debugger, but in Chrome, it's called the Sources. On the website, click on the contact page. Each time the page loads, you might notice a rapid flash of red on the screen. We're going to use the debugger to work out what this red flash is. And if it contains anything interesting, debugging a red dot wouldn't be something you do in the real world with Pentester, but it does allow us to use this feature and get used to the debugger. It's on the contacts panel, right? Is that what it said? What's the problem here? Yeah, contact page. In both browsers on the left-hand side, you see a list of the resources the current web page is using. If you click on the assets folder, you'll see a name, flash.min.js. Clicking on the file displays the contents of the JavaScript file. Let's pull this out a little bit. Many times when viewing JavaScript files, you'll notice that everything is on one line, which is because it has been minimized, which means all formatting, tab spacing, and new lines have been removed to make the file smaller. This file is no exception to this and has also been obfuscated, which makes it purposely difficult to read, so it can be copied. Oh baby, security through obscurity. We can return some of the formatting by using the pretty print option, which looks like two curly braces, brackets, braces. To make it a little more readable, although due to the obfuscation, it's still difficult to comprehend what's going on the file. If you scroll down to the bottom, flash.min, you'll see the lines flash remove. This little bit of JavaScript is what is removing the red pop-up from the page. We can utilize another feature of debugger called breakpoint. There are points in the code that we can force the browser to stop processing the JavaScript and pause the current execution. Hello, sorry for bothering you. I want to offer promotion on your channel. No. No, thank you. No. No. No, no, no. No. Let's do it then. Let's look. Ooh, man. Oh wait, it was Flash, wasn't it? I think it was Flash. .min.js, yeah. Remove breakpoint online, disable breakpoint online, add a condition, add log. Is that the breakpoint? Did I add it? Is that adding it? Okay, cool. So we stopped it from being removed, and we can see it's Tryhackme, catch me if you can, which we will put down here. Tryhackme. Catch me if you can. Cool. And next. DevTools network. The network tab on the developer tools can be used to keep track of every external request a web page makes. If you click on the network tab and then refresh, you'll be seeing the files the page is requesting. Yes, we do with what we were on a second ago. Let's just remove this breakpoint. Yeah, go ahead, move through it, and then we'll just get rid of it and not add 3 more. Cool. You notice on an event and then a network tab, and oh wait, well the network tab is open. Try filling the contact form and pressing the send message button. You notice an event in the network tab, and that is the form being submitted in the background. Stop it. Oh, what was that noise? What was that noise? Oh, you followed. Hey. Hey, thank you so much. Are you working through anything? You working through any of these boxes? You working on any certifications or labs? Anything like that? Hey, Pixa. How's it going? You notice an event in the network tab, and this is the form being submitted in the background. Using a method called Ajax. Ajax is a method for sending and receiving network data in a web app background without interfering with changing the current web page. So we're still in the contact form, and it wants us to enter in information. Let me take the caps off. Whoa. I was bored, but not anymore. Thanks to you. Thank you. Well, I hope I hope I can be somewhat entertaining. Just going through like the basic Tryhackme lab on web apps. So I've been going through the I guess the PJWT, which is the TCM Securities web application course. It's actually called, I think it's the Bug Bounty, Practical Bug Bounty course. So I've been going through that, and I decided I'd completed that, and I want more training. I'd already done like 57% of this whole thing. Like I'd completed all the actual boxes. But none of this like how-to stuff, and I figured I might as well go back through it, just get it finished, and see what happens. See if I learned something that maybe I didn't know before. Oh, I'll send the request. Contact form sent. Wait, wasn't it here that it was talking about? Oh, contact message. It is. Okay. Gotcha. And then we can see the flag. Okay, cool. Dun dun. Cool. Okay, so let's go to the next room. Okay, interesting. Yeah. Are you doing anything, Pixa? Like, are you in like interested in computing, hacking, pen testing, CTFs? Software development, anything like that? Starting machine. So now we're in the content discovery lab, and we've got our machines going. Let's see. Firstly, we should ask, in the context of web application security, what is content? Content can be many things: a file, video, picture, backup, a website feature. When we talk about content discovery, we're not talking about the obvious things we can see on websites. It's things that aren't immediately presented to us and that weren't always intended for public access. In this course, this content could be, for example, pages or portals intended for staff usage, older versions of the website, backup folders, file configurations, administration panels, etc. There are three main ways of discovering content on a website, but which we will cover: manually, automated, and OSINT. To start the box, click the start box, which we've done. We've got a few seconds left, and it'll pop up. What CDN content discovery method What is the content discovery method that begins with MAO? Well, I don't know. I'll tell you when this lab shows up, though. Let's see. The 3 main ways of discovering content on a website, which we'll cover. Oh, is that what it was? Manually? Go back. That's what it, okay. Automated and OSINT. ISINT. OSINT. And robots.txt. Which I've actually heard people aren't using as much because of this reason. It leaks sensitive information. You found the robot.txt endpoint. Thanks. Is that all that it was? Okay. What is the directory in the robots text file that isn't allowed to be viewable by the crawler's staff portal? Yikes. Does it need the slash? It might need the slash. It does need the slash. Slash staff portal. Woo! Manual discovery, fave icon. The fave icon is a small icon displayed in the browser's address bar and tab used for branding research, which we see nowhere. I mean, we see it. No, we don't see it here either. Oh, there it is. Okay. Let's go back. And I keep dragging it out. Let's pull it up in inspect, network, refresh, reload, see the favicon, and then there's this random X-flag header. I imagine that that's what it wants us to look at. Oh no, it wants us to make a curl request. Okay. If you run the following command on the tab box, it will download the favicon and get its MD5 hash, which we can then look up on the OWASP favicon database. This curl will fail on the attack box if you're a free user, in which you should use a VM for this. If your hash ends with 427E, then it failed. Okay. Well, let's do a little thing. Pixis says, yes, I'm interested in all of these things. Also in hardware. I'm 17. I'm in school that can teach me these things. And in my free time, I try to bypass login on different types of things. And I'm also interested on how cheat sheets work and how anti-cheats work. Oh, how cheats work and anti-cheats work. It's really rare to see someone do this live. It's mostly YouTube vids or written text. Yeah, I do agree. You don't really see it. Hey, but since you're talking about bypasses, oh man, I wonder if I still have it. Let's see. So if you haven't already, you might be interested in the Advent of Cyber side quests. I'm not sure which one it is, but there's one of the rooms that's kind of required. Well, actually, I don't know if it's unintended or not, but the way that I got through it was using a 403 bypass. So which one was it in? I think it's in Tryhackme. Tryhackme. Let's not look at flags. Was it this one? I think it might have been this one. Yeah. Did I get the link to where I got the bypass? Right, because 401, 401 bypass versus 403 bypass, and then we'll open up another one. 403 bypass. Maybe Hacktrix has something on it. I'm not sure. Yes, it does. Okay. I don't want that. I kind of want them to be like, hey, there is a difference, right? Like between 401 and 403, but essentially you can do some fuzzing and potentially get around 403s, which is pretty cool. Yeah, here it is. So let's see, you might be able to do uppercase, add the trailing slash, add a slash, and then a period for like current directory, right? You could try to like double slash or period slash period. Anyway, there are like a ton of different types of ways you could potentially bypass a 403 authentication page. Really, really cool. Really, really cool. But anyway, let's see what the room's called. You might be interested in it real fast. Let me hop out of this or over to like a different room. It is kind of difficult, and I'm not sure if you need to solve like the challenge. There was a challenge before, like during the contest or the CTF, whatever, during the advent of cyber, there was a time where there was like a pre-hack, right? It was like your entry into it was hidden. Come on, and let me search. I want to see if the side quests. I'm not sure if the side quests are a thing. Cyber side quests. Okay, cool. Cyber side quest. Yeah, but this is kind of like, oof. This isn't even like the hidden rooms. This is just the side quest room. So like there was a main room, and then there were 4 other rooms, and then you would put your flags. So you'd have like 3 sets of flags. You'd have a flag for this page. Yes. Yeah. See, here we go. Cyber side quest. Shit. I'm not sure which one it is. Did I say what it was in this post? Anyway, you might like it if you're trying to bypass login on different types of things. Yeah, you might find this room informational at very least, and maybe helpful, you know, if you are trying to do different types of bypass. It says on the web pages. Which one did it? Snowy Armageddon. Let's see. I think it's, let's see. Okay, Snowy Armageddon. Get out of here. Okay, so it's this one, Side Quest 2. Which maybe you can just click on it now. Okay, cool. So you don't even have to mess around with all that mess. You can just, I guess, go straight to it, and we'll see what happens. If it looks like stuff's popping up, I won't just show it, just so you can, you know, kind of go through it on your own if you choose. If it loads, hello, can you load faster a little bit? Anyway, yeah. So now you can kind of see where it is. Is that me? Oh, that me. Yeah, it took quite a while to get through it. It was really fun, man. Really fun, a little difficult. Yeah, I think you might like it based on your interests. Anyway, we'll run back over, pick back up where we left off. Do you think Static Labs needs to be my IP? Yikes, get out of here. CGIIRC. CGIRC. What frame? Yeah, okay. That did work. I guess I can read through it. Yeah, we really just curled and piped that to MD5 sum. And apparently you can do it with PowerShell. The curl, this curl will fail on attack box. Yeah, right. Because attack boxes don't have access to the internet, is my assumption. We look at XML headers. Let's see. Unlike robots.txt file, which restricts what search engine crawlers can look at, sitemap.xml file gives a list of every file on the website the owner wishes to be listed on a search engine. These can sometimes contain areas of the website that are a bit more difficult to navigate to, or even list some old web pages that the current site no longer uses. So we'll navigate there. We'll get rid of these. Actually, we'll keep that one. Article. Secret area. Oh, baby. And you found the sitemap endpoint. I imagine it's going to want the directory, which it does. And it wants a forward slash. Oh, God. Hey, take that. There we go. Cool. So it's saying, look at sitemaps. Manual discovery, HTTP headers. When we work requests to the web server, the server requires HTTP request header, various header, HTTP headers. Jesus. These headers can sometimes contain useful information, such as web server software and possibly the programming scripting language in use. Curl, tag fee, verbose. What is the X flag header? Yeah, wow. That's the X flag header. It wants us to, okay, whatever. We'll go through it. Curl HTTP 10.10.175.36 tag fee. Grep for X flag. And there it is. Copy. Could have just copied off that other page, but I might as well go this way. Save it. Thank you. Taking ages to update bits and pieces. Framework stack, manual discovery, framework stack. Once you've established the framework of a website, either from the above favicon example or by looking for clues in the web page source, such as comments, copyright notices, or credits, you can then locate the framework's website. From there, we can learn more about the software and other information, possibly leading more. What is the flag of the administrator's portal? Yeah, that was oh hell. Oh hell. Where did it go? Or where was it? Page source. Was it? Was the framework? It was admin, but there was a login somewhere. Admin for the username, password. Changelog maybe. No, not there. Documentation. Yeah, here it is. Okay. So we can go to the framework login with admin. Hello. And log in. And change your credentials, son. Please stop coming off the screen. Cool. OSINT Google hacking dorking. Yes. Cool. Google hacking dorking utilizes Google's advanced search engine features. You can append things like site, year, in URL, file type, and title. Quotation marks is like show me things that have like exactly what I've asked for. What Google dork operator can be used to only show results from a particular website? Is that site? Does it want the colon? Yep. Okay. And Woppalizer, which we have here, is a plugin. What online tool can be identified? What technology is running? It's an online tool. What's the question? What online tool can be used to identify what technology? Oh, Woppalizer. Okay. Woppalizer. Wappalizer. Web Appalizer. Wop, wop, wop. The Wayback Machine. The Wayback Machine here is a historical archive of websites that dates back to the late 90s. You can search a domain name, and it will show you all the time and services scraped. Times the service scraped the web page and saved the contents. This service can be uncovered. I can help uncover old pages that may still be active on the current website. What is the web address for the Wayback Machine? It's right here. You provided it to us. Thank you. Thanks. And GitHub. To understand GitHub, so like something like this, you might look for GitHub. You look back in like old versions to maybe check for like old credentials, stale credentials, default credentials. Maybe they've said that they changed them, but they live somewhere else on a web page. So you can just kind of go back into the version history in GitHub and maybe find creds, configuration errors, so on and so forth. Git is a version control system that tracks changes to files in a project. Working in a team is easier because you can see what each team member is editing and what changes they made to files. When users have finished making their changes, they commit them with a message and then push them back to a central location repository for the other users to then pull those changes to their local machine. GitHub is a hosted version of Git on the internet. Repositories can either be set to public or private and have various access controls. You can use GitHub's search feature to look for the company names or websites names to try and locate repositories belonging to your target. Once discovered, you may have access to source code. What is Git? A version control system. Thank you. And OSINT for S3 buckets. Those are Amazon buckets. Amazon AWS storage. Yes. S3 buckets are storage service provided by Amazon AWS, allowing people to save files and even static website content to the cloud, accessible over HTTP and HTTPS. Ooh. The owner of the files can set access permissions to either make files public, private, and even writable. Sometimes these access permissions are incorrectly set and inadvertently allow access to files that shouldn't be available to the public. The format of S3 buckets is HTTP or S :/the name.s3.amazonaws.com, where name is decided by the owner. What is the URL format? It's right here. Thank you. Wait, what? .s3.amazonaws.com. I thought maybe it would want. I guess it doesn't care about the subdomain name, whatever, because there's not one, right? Such as Tryhackme assets S3 Amazon AWS.com. S3 buckets can be discovered in many ways, such as finding the URL in the website's page source, GitHub repository, or even automating the process. One common automation method is by using the company name followed by common terms such as name, assets. Oh, nope. Name assets. Okay. So dash assets, www, public or private, etc. So literally just prepending like Tryhackme dash to each of these. Nice. Put that down in the web hacking part of your notes. Automated discovery. What is automated discovery? Automated discovery is a process of using tools to discover content rather than doing it manually. This process is automated as it usually contains hundreds, thousands, or even millions of requests to a web server. These requests check whether a file or directory exists on a website, giving us access to resources we didn't previously know existed. This process is made possible by using a resource called wordless. That machine, our access is denied to Tryhackme's S3 bucket, which that makes total sense. What is this? We'll echo this. Nope. Copy. We'll echo this to base 64 tac D. Ooh, and it's a big bunch of junk. So, great. Nice. Thanks. Clear. We'll get rid of that. It's going to show us Daniel Messler's sec list, word list. And it wants us to fuzz what? Oh, it wants us to fuzz directories. Okay. I can do that. So we're going to use fuff for the word list, user share, word list, mine's sec list, discovery web content common dot text. I'm going to enter the URL, tacu, http:// 10.10.175.36, and then we're going to tack fuzz onto it because the way that fuff works is it will start sending everything inside of this common.txt file in this path into the fuzz parameter. So we should get a ton of crap coming back, and Jesus, actually, can we do like, is is no error a thing? I'll put on keys, directory. I don't want error messages to show. So little. Whatever, let's run it again. And it's not gonna run because I have no error appended to it. Oh, okay. I think maybe the problem was that I just didn't have it opened up enough. On the attack box, execute the following three. So it's gonna go through. Oh, ads are about to start. Ads are about to start in 1 minute. Right. So the only thing that we haven't looked at these 3, 4. We haven't seen these 4. Nope. Yeah, we've seen news. Anyway, so it's going to show us you can use fuff, derb, or GoBuster. I usually use GoBuster. They're all fine. It's just a matter of preference. It has absolutely nothing to do. I don't think it has anything to do. I don't know. I'm sure somebody out there can tell us that one of these is faster, but I don't notice it. I just tend to use GoBuster or dirbuster. What is the name of the directory beginning with MO that was discovered? Monthly. What is the name of the file? And it was what? Development log. Okay. Development.log. Dun, dun, we did another room. Okay. Next. Just lining these things up, man. Subdomain enumeration is a process of finding valid subdomains for a domain. But why do we do this? We do this to expand our attack surface, try and discover more potential points of vulnerability. We'll explore 3 different subdomain enumeration methods: brute force, OSINT, and virtual host. All right, and we'll give it a minute. Let me try something. I'm gonna put that there in case you need to go, in case you want to go watch it on YouTube. That way you're not inundated with ads constantly. Are we up? We're up? Okay, cool. Let's just, before we literally do anything, any paying attention, let's go there. Subdomain enumeration is the process of finding valid subdomains for a domain. But why do we do this? We do this to expand our attack surface and to try and discover more potential points of vulnerability. Right. So we're gonna brute force. Okay. Well, brute force domains coming up, I guess. Subdomains, brute force, OSINT. What is the subdomain enumeration method beginning with V? It's virtual host. Virtual host, which GoBuster has a vhost option. SSL TLS certificates when it's SSL TLS cert secure socket layer or transport layer security. The certificate is created by domain for a domain by a CA certificate authority. CAs take part in what's called certificate transparency logs, CT logs. These are publicly accessible logs for every SSL TLS certificate created for a domain name. The purpose of CT logs is to stop malicious and accidentally make certificates from being used. To stop malicious and accidentally made certificates from being used. We can use this service to our advantage to discover subdomains belonging to domain sites like https cert.shell or https ui.search, search.intrust.com. Holy. What domain was logged on blah 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 on 2020 12/26? We'll take that with us over to cert.show. Hey, so I went ahead and posted a link to the YouTube page, the live stream on YouTube. That way you could maybe escape the ads if you weren't feeling that. I know they can be annoying to say the least, so just pop that over there for you. We're not there. We're not cert.shell. Cert.shell. Identity search. What am I looking for? What the hell? Go to the and search for the domain name. Tryhackme. Oh, okay. Tryhackme.com. And then we are looking for this date and time. Store.try. What does it want? Oh, store. Okay, it is store.tryhackme.com. Yes, sir. Or yes, Pixa. Pixa says +1. Search engines contain trillions of leaks to more than 1 billion websites, which can be an excellent resource for finding new subdomains using advanced search methods on websites like Google, such as Site Filter, can narrow the search results. For example, oh right, so it's saying you can subtract, like if you don't want to see www.sites, basically through OSINT using Google, you can like bit by bit remove websites that kind of keep appearing, like if you see a ton of wwws. So they're saying what we can do is remove site www.domain.com and then add all asterisks, so all.domain.com. So it should show us everything from .domain.com excluding www.domain.com. Would only contain results leading to the domain name domain.com, but exclude any links to www.domain, and therefore it shows only subdomain names belonging to domain.com. Go to Google and search this, which is yep, okay. It's literally the same exact thing. It's going to we're going to remove www.tryhackme.com and search for everything else, asterisk. So help and store are what we see. What is Tryhackme subdomain beginning with S? It is store.tryhackme.com. And What is the first domain found with the DNS recon tool? What's this one? Brute force DNS. Enumeration is just method of trying tens, hundreds, thousands, or even millions of different possible subdomains from a predefined list of commonly used subdomains. Because this method requires many requests, we automate it with tools to make the process quicker. In this instance, we are going to use a tool called DNS Recon to perform this. Click the View Site Page button. To open the static site, press the Run DNS Recon Request button. Okay. Acme IT support. I imagine we have this DNS Recon. Yeah. So Kali comes with it by default, is my assumption. What is the first subdomain found with the recon tool? API.acme IT support.tryhackme, THM. API.acme IT support.tryhackme. Yep. Cool. And then let's check out Sublister. Open up that website. To speed up the process of OSINT subdomain discovery, we can automate the above methods with the help of tools like Sublister. Click the View button. Yep, Sublister, got it. Let's run it. So with Sublister, it goes out and it checks each of these for subdomains. Like if you were to do this with yahoo.com, it comes back with so many. So web55.acme, Acme IT support.tryhackme. Is Kali directly installed on your machine, or are you using a virtual machine? Aspects. I am using a virtual machine inside of, what the hell is this called? Inside of VMware Workstation. I do have VM VirtualBox on here as well, but this is a VM. And let's submit that. What do you use? Are you using a VM? Or honestly, I don't know if you have a subscription to Tryhackme, or if you even use Tryhackme. But their little attack box that they have is quite nice. It's not this, but like I don't mind the split screen. You can actually pop it out. It's kind of cool. I've used it like when I didn't feel like when I wasn't on this computer, or when I didn't feel like I don't know, spinning up the VM, connecting to the VPN, so on and so forth. It really came in handy. Virtual hosts. Some subdomains aren't always hosted in public accessible DNS results, such as development versions of a web application or administration portals. Instead, the DNS record could be kept on a private DNS server or recorded on the developer's machines in their Etsy host file, or see Windows System 32 drivers Etsy host file for Windows users. That's actually a decent path to know. I don't have this. I should know this, which maps domains to IP addresses. Because web servers can host multiple websites from one server when a website is hosted, here we can show you nano Etsy hosts. So this is my Etsy host file right now, and we can see on here that in most cases I only have one, but sometimes there is the domain here, and then we have like a subdomain. So I added both of them to that. Let's see if there's anything. Yeah, okay, here we go. So here we can see like app, yikes, app.napper.com, and we have internal.napper.htb, and we have ca.napper as well, so certificate authority. Yeah, this is kind of what it looks like. Yikes, I am just making it massive. Can we get smaller? Thank you. I've added these comments in just to like kind of separate it, make it look a little bit better and easier for me to read. Because web servers can have multiple hosts, one server the website requests from a client, the server knows which website the client wants the host header. We can utilize the host header by making changes to it and monitoring the responses to see if we've discovered a new website. like with DNS brute force, we can automate the process by using a word list, commonly used subdomains. What are they going to use? DNS nameless.txt. And they're going to use FUF. We can try, instead of FUF, we can try GoBuster. So they're doing bhost. And they're using DNS namelist. And no error. Error running GoBuster unable to locate. Oh, right, because we're not looking at Nagoya. We are looking at Tryhackme. Which is, ooh, is this gonna work? Acme IT support Tryhackme. I don't have this. Oh, that's, is that why they, okay, hold on. let's start over. Let's start over. Okay. Let's add this to our Etsy host file, sudo nano Etsy hosts. And what's our IP? Or what's it? It's IP 10.10.53 dot what? 255? What? 255. Okay. Whatever you say, coach. And it's Acme IT support. Tryhackme. Save it. And we'll see if this even works. And the answer is no. Error unrunning GoBuster unable to connect to Acme IT support.tryhackme. Yeah, it can't send the request. Ping 10.10.53 255. So it can get there. Acme IT support.tryhackme. I guess we can try it with there. Okay, nice, Pixa. So Pixa says, I'm waiting to find a good deal on a laptop for school, and I'll use it on dual boot mode. So basically he's gonna dual boot like Windows and like Linux or something. But I don't have one for now. So you're trying to learn theory and start practicing when you have a laptop. That's good. That's good, yeah. It's, I mean, honestly, you can do a lot with just Windows. Like, I'm telling you, the attack box on Tryhackme is pretty nice. Pretty nice. It's not bad. I think like free, I think for, if you're doing free, I think you get like either an hour a day or an hour a week of using the attack box. So you don't have to just learn theory. You can create a Tryhackme account and then start going through it using their attack box, and it would kind of run like this, right? So you'd have the guide on the left, and then you'd have an actual browser-based VM on the right. So that would kind of give you some like hands-on experience outside of hardware hacking, which is super cool, might I add. I'm just gonna try and take their I'm just gonna try and take their command. I'm assuming I just can't access it internally, and I'm not sure what the size is. Let's get like a little snippet. Okay, so we'll filter on size, tac fs on size of 2395. So basically what we're going to do is we're going to exclude web responses with a size of 2395. So now we're not like inundated with all of that mess that was showing up before. We can see it running. It's like really freaking running. And it's making 1 million and freaking requests a second. It's running on 40 threads. API API. What was the first subdomain discovered? API. I mean, it was API for me. Does it want like slash API? What does it want here? API? Bruh. The above command uses the W switch to specify the word list we're going to use. The H specifies, and I'm using that same list. The fuzz keyword space where subdomain can normally go. This is where we try all the options for the word lists. Because the above command will always produce a valid result, we need to filter the output. Yeah, so we're filtering on size. Command filters fs switch, which tells tells FUF to ignore any results that are the specified size. Where is it getting like anything that's not? Do I need to slow? I might need to slow down. All right, let's try this again. Is it tag T for threads? Is T threads? Let's find. We'll find it. Yeah, okay. So -T is threads. It's gonna go like significantly slower now, but we may have just been like skipping over some previously or something. I'm not sure what the what the issue was. I might even need to remove that line from my Etsy host, and as a matter of fact, I'll just go ahead and do that. We're getting these messages because I've opened up this freaking window. Hello? Yikes. Freaked out there. So if you go down and scroll down, you can hit Control K and it removes the entire line, and then Control X, hit Y, hit Enter, and we've now saved it. And then, yeah, I want to close this. I don't understand what it's saying, what it's like asking. Okay, we can probably open the attack box. Start attack box. The command has a similar syntax, blah, 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 blah. Again, API was my first. Zooming, pausing. Just API. Status 200, yeah. Significantly slower than what it was before. I don't know if this is even gonna work. Web 555. Web 555. What you want? Name list. API. Dub. Fuss.acmeitsupport.com. Yeah. What is the first subdomain discovered? It's API. API again. API. Yikes. Stop that. No. I guess enter pauses. Interesting. I did not know that. And then enter again resumes. That's cool. We didn't follow redirect. Yeah. Oh, that's normal. API. And again, it's not wanting slash API. Yikes. Slash API. No. The above commands have revealed 2 positive results that we haven't come across before. Is it like wanting Shit, I'm just gonna speed it up a lot. Let's do a 100. We are really moving through them now. API, yep. We know about that one. We know about www as well, so. And we're using nameless. Yeah, I mean, we use their command, so. Come on, baby. Oh, hey, Pix, I see you subscribed on YouTube. Thank you. I don't know why it didn't ring. It should have told me. It should have told me you subscribed. Did it? And I just didn't hear it? Can I replay it? Yeah, I must have something messed up. Yeah, because I see followed as well. And I think I got that one. I think that the YouTube just didn't work for one reason or another. I probably need to set the alert box up. Okay. Okay, there's a new one. Delta. Delta? Okay, so that's what it is. I just need to be more patient. Yeah, that makes sense. I'm not very patient. Although I will say this is taking like significantly longer than I thought it would take. And I'm like, I don't know, maybe I'm really surprised. 2 minutes at 100 threads. Nearly 1,000 requests a second. It might even miss it, is kind of my worry. Is that it's gonna get through all the way and I'm gonna have to start over at like a slower speed because it misses it. Which would be slightly annoying. Yeah, only YouTube. Yeah, unfortunate. It'll be okay though. I'll get that sorted at some point, and it'll be better. Oh, we got another one. Yellow. Okay. What a stupid. Why would they put it so far down? Yellow. Holy moly. Okay, that was crazy. Crazy long time. Yo, check that out. It actually went through every single request. 3 minutes of waiting at like nearly 1,000 requests a second. That's insane. Absolutely. Okay, cool. Whatever. We'll start this next one. Authentication bypass. Learn how to defeat logins and other authentication mechanisms to allow access to unpermitted areas. Hey, this is right up your alley. In this room, we will learn about different ways websites authentication methods can be bypassed, defeated, or broken. These vulnerabilities can be some of the most critical, as it often ends in leaks of customer personal data. Right. So we have done this. We're starting the machine right now. Actually, aren't we starting the machine? Hello? Come on. Maybe I should have stopped the other machine first. Uh-oh, you can only deploy them. Yeah, okay. Let's go back. We'll terminate this one. Goodbye. Go back again. Terminate this one. Yeah, that's what I need to do. I need to go back and start turning them off. Okay, and then we'll terminate that one. Okay, now we should be fine to go back and start again. Start machine. There we go, much better. Okay, let's read on. User enumeration. A helpful exercise to complete with trying to find authentication vulnerabilities is creating a list of valid usernames, which we'll use later in other tasks. Website error messages are great resources for collating this information to build our list of valid usernames. We will have a form to create a new user account if we go to Acme IT support, which we'll have in 30 seconds. Sign up page. If you try entering the username admin, fill in the other form fields and fake information, you'll see we get an error account with this username already exists, right? So there's our error message that we'll put in FUF apparently, right? They're gonna use it. Username already exists, yeah. And this is like what is it? I don't know what MR is, but something response, I imagine. Making the request, whatever. We can use the existence of this error message to produce a list of valid usernames already signed up on the system by using FUF tool. The FUF tool uses a list of commonly used usernames to check what they're going to use. Yeah, okay. Usernames, names.txt. And we're up and running. Okay. So we can just take this. It would be more beneficial to us to just like type it in ourselves, I guess. Oh shit. Go back up. So it's FUF. And I'm gonna go up to seclist, and then I'm gonna hit Control and K, and it's gonna get rid of everything after that. That way we can go into usernames, names.txt, and then we're gonna tell it that we're going with capital X. We're gonna tell it that we're gonna send a post request, and the data that we're going to send is username, and we're gonna set that equal to fuzz, and then we're gonna set email equal to X. Okay, that's fine if it allows that. And then we're going to set the password. We're going to also set password to X. And then we're going to set cpassword to X. And then we're going to set the header information of content type. Hey, we've got another ad coming in 1 minute. Just be prep. You can move over to the YouTube stream if you don't feel like watching ads. That's perfectly fine. Recap. FUF, we're putting our word list, or dash capital X because we're going to send a post request. Otherwise, it would send a get request. The data that we're going to send is username, fuzz, email, X, password X, cpassword X. The content type header that we're going to put, so tag H for header. Content type of application. X, www form URL encoded. And then we're going to specify the URL that we're going to make the request to. 10.10.169, tag 1, customers, sign up. And then whatever MR is, we'll look it up in a minute. Username already exists. Yeah, it's only the YouTube that... Oh, wait, what am I seeing? What just happened? I saw like a flash. I don't know what that was. How odd. Okay. Let's run this and see what happens. So we can see admin. Oh, the admin user. What is the username starting with? SI, ST, and RO. Okay. Yikes. Let's pause that and we'll start it again. I kind of wish it would stop breaking like that. That's even worse. What happened, bro? I'm gonna run it again. I saw one of them. It was like ST of Steve. Oh, this is horrid. I'm just gonna expand it back out. It's even worse this way, but admin. Somewhat difficult to read through this. Robert, Simon, and Steve. Simon, and Robert, right? Roberto, Steve. So that's username enumeration. Let's go to brute forcing. I'm actually gonna make this tiny again. Get down. Tiny is relative, right? I'm gonna make it smaller. How about that? Yo, what is Dirge Briar? Dirge? Are you Dirge? Are you Scourge? How's it going? How are you? Thanks for joining. Thank you. So we're just going through Tryhackme's web. I think it's just web basics. What is it called? I mean, obviously right now it's the authentication bypass room, but overall it's one of the learning paths that we're working through. Yeah, so let's view the path. I think it's web fundamentals. Yeah, it's called web fundamentals. Made it through how the web works. I've actually done a lot of this already. You can see here, I've done all of the actual like CTF boxes that they have as like challenges. And then we're just kind of making our way down through this introduction to web hacking section. It's going to go over each of these different topics in some detail. And this is kind of like supplementary for me. It's supplementary for the PJWT, Practical Junior Web Tester certification from TCM Security. I've already gone through all of the TCM Security courses, but I'm going to go ahead and go through these. Maybe these will cover something or kind of help me understand other topics. Although TCM courses are known to be like very well formatted and like that's all the information you need, I can vouch for that. When I took the PJWT and PNPT, passed them both, and the only material that I needed, excluding like VPNs, not VPNs, proxies, at least when I took it, were the courses were enough. The courses that they provided for the PJPT and PNPT were enough. I also highly recommend them because they are relatively cheap. I'm not sure if they do like localization. So if you're not from the United States, $200 US might be quite a bit. And that's very fair. It's very, very fair. Hopefully, you might even be able to reach out. I know that reach out to them about localization, like in your area. Anyway, let's move on into brute forcing. Cool. Using the valid usernames text file we generated in the previous task, we can now use this to attempt a brute force attack on the login page. So I'm sorry, did it want me to what does it want? Let me see if this where am I? Not there. Let's cd to desktop because I can get rid of shit really fast from the desktop, and we will put that into usernames.txt, and we'll see what happens. Let me just cancel and then cat usernames.txt. Awesome. Kind of. Ooh. So what if we did this and then pipe that into awk, right? Awk. What? Awk print $print 1. Is that right? Let's see what happens. Big bunch of nada. Why does nothing happen? Regex username already exists. What? Username, email, password. Oh, because we created all of those accounts. Username already exists, which is what we're searching for. So it should only be returning. It should still return them. Right? Admin. Oh, maybe your name is Dr. Gabrier? Admin Robert, Simon, Steve. Easy Nano, admin Robert, Simon, Steve. Anyway, thank you for being here. And that was it. Okay, XY, enter. So now, with our nice new word list, we can do FUF with word list, valid user stat. Okay, so we're specifying our word list to value 1. Yes. We're specifying our word list to W1. We're specifying our password list to W2. We're creating a post request. The data that we're sending is username equal to W1 and password equal to W2. The header information that we're sending is content type application x www form dash URL encoded, and then we're going to send that over to their customer login. And then we're going to filter on content 200. So it's going to return only successful logins. So let's see what happens. I'm going to need to change. What do I need to change here? I didn't call it valid usernames. I called it usernames. Didn't I? Did I not? Cat usernames, cat usernames. Oh, what was the other one? Stop it. User list. Okay, let's remove user names dot text and move user list to usernames dot text. I don't need to do that, I guess. I'm still gonna have to change it, aren't I? Username? No, I'm not. Cool. So we got Steve with Thunder. So Steve with Thunder, and then let's just validate that, right? Let's go log in. Let's go see what's here. Copy pasta. Steve and Thunder. Right? Dun, dun, look at that. We've logged in. We can see no support tickets. Oh, look at that. He's got a nice email format. Steve at customer.acmeitsupport.com. Then we can come in here. Jono at fakemail.tryhackme. We can come in and change his password, update his email address. So we start getting his support tickets if we wanted. Be like nice and malicious. What happens? Can we send him a thing? Steve, what is his name here? Or what was his email? This copy. This Steve. Whoa. Contact form sent. Customer support tickets. Oh no. Does this work? Ticket subject. Wow. Ticket contents. Garbage. Create ticket. It does. It sets an ID of 3. Does that mean that there are other things that we can look at? ID of 2. 1. 0. 9999. The answer there is no. Okay, cool. Well, whatever. Now we'll look at logic flaws. What is a logic flaw? Let me get a drink. Everybody else, take a drink. What is a logic flaw? Sometimes authentication processes contain logic flaws. A logic flaw is when the typical logical path of an application is either bypassed, circumvented, or manipulated by a hacker. Logic flaws can exist in an area of a website, but we're going to concentrate on examples relating to authentication in this instance. The hacker's path is going from step 1 to step 4. The intended path is 1, 2, 3, and 4. And let us see when a logic flaw occurs. The below mock code example checks to see whether the start of the path the client is visiting begins with admin. If so, then further checks are made to see whether the client is in fact an admin. Is equal to exactly admin. Check the code. Okay, well, whatever. The page shown below. Because the above PHP code example uses 3 equal signs, equal, it's like absolutely. It looks for an exact match on the string, including the same letter casing, right? So all lowercase admin. The code presents a logic flaw because an unauthenticated user requesting admin will not have their privileges checked and have the page displayed to them, totally bypassing the authentication check. Hey, there you go, Pixa, another way to authenticate, bypass authentication. You just change some casing. You know, if it's PHP and it's using this exact match string, or if that's what it's, yeah, anyway. The logic flaw practical. We're going to examine the reset password function of the Acme IT support webpage here. We seek a form including asking for the email address associated with the account on which we wish to perform the password reset. If an invalid email is entered, you'll receive the error message, account not found from supplied email address. For demonstration purposes, we'll use the email address robert@acmeitsupport.thm, which is accepted. We're then presented with the next stage of the form, which asks for the username associated with a login email address. If we enter Robert as a username and password, and press the check username button, you'll present with the confirmation, press the blah, 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 blah. At this stage, you may be wondering what the vulnerability could be in this application. Email, username, and the password link is sent to the email address of the owner. This walkthrough will require running both of the below curl request and attack box. On the attack box, which can be opened by using the blue button. Okay. I don't know. I guess we have to start it. Whoa. Chill out, attack box. Taking over the screen here. The walkthrough will require running both curl requests on the attack box. Yes, we saw that. In the second step, the reset. In the second step of the reset email process, the username is submitted in a post field to the web server. And the email address is sent in the query string request as a get field. Okay. Let's see what it's doing. So it's sending a curl request to customers reset with the data of email set to Robert at, this is ampersand, nope, this is the at symbol, URL encoded at acmeitsupport.tryhackme. with the header information of content type, application, X, www form, URL encoded, and the data of username equal to Robert. We use the tag H flag to add an additional header for the request. I might actually need to wait to copy this. I'm going to try now, but I might have to wait because it has like its own little clipboard that you can have to wait, copy to. So again, we're setting the content type to application, X, www form, URL encoded, which lets the web server know we're sending form data so it properly understands our request. In the application, the user account is retrieved using the query string, but later on, in the application logic, the password reset email is sent using the data found in the PHP variable request. The PHP request variable is an array that contains data received from the query string and post data. If the same key name is used for both the query string and post data, the application logic for this variable favors post data fields rather than the query string. So if we add another parameter to the post field, we can control whether the password reset email gets delivered. Curl request username T and email equal to. Okay, so it's saying request. PHP variable request. Variable is an array that contains data received from the query string and post data. If the same key name is used for both the query string and the post data, get out of here. Favors post data forms rather than the query string. So if we add another parameter to the post form, we can control where the password reset email gets delivered to. So here we're saying for username Robert, and we're going to send the reset to attacker@hacker.com. Will this work? No, it's not there. Okay. So we'll snag this one real fast, and it's going to, oh, it's just going to reset the email. Okay, well, let's just see what the output is. Clipboard, please start copying things. Copy, paste, paste, Control Shift V is paste on this. We'll clear that out. Yep, got it. And we'll take our second curl request, which I'll probably need to open this up again. Paste that. We'll receive a request email to attacker@hacker.com. So again, they're showing you like what the web page is showing, and of course we're seeing the HTML for the web page. Regardless, we can still see exactly what they're showing us, which is that it's going to send, or it says it's going to send to attacker@hacker.com. For the next step, you'll need to create an account on the Acme IT support customer section. Doing so, giving you a unique email address that can be used to create support tickets. The email address is in the format of username at blah, 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 blah. Username at customer.acmeitsupport.tryhackme. THM. HTTP 10.10.169.1. Customers. It does want us to create an account. Acme customer.acme IT support Tryhackme password of password, password of password. Those don't look like they're the same length. Okay. Right. I still have it there. Okay. We'll copy it again. And we'll head back over. So we need to change username to my name. We'll send the reset email here. Nice, and now we can see Robert's request. Robert's flag. Can I extend this? I can. Ooh. Right, so now we're gonna navigate to this endpoint because this is the reset email that he would have received. Where is it? No. Paste. Wait, did I do it? Whoops. I completely blinked. I must have blinked. Anyway, the flag is Tryhackme, auth, bypass, complete, compete. Auth bypass complete. Wonderful. Now we're gonna look at cookie tampering. Dink. Cookie tampering. Examining and editing the cookies from the web server during your online session can have multiple outcomes, such as unauthenticated access, access to another user's account, or elevated privileges. If you need a refresher on cookies, check out the HTTP in detail room on task 6. Plain text. The contents of some plain cookies could be in plain text, and in this instance, obvious, and it is obvious what they do. For example, if these were cookies set after a successful login here of login equal to true and max age equal to 36 and path equal to root versus admin equal to false. Login true, admin, right. So do we have cookies? Is that what it's trying to tell us? Store session. Can we just create our own? Okay, it just wants us to curl cookie test, which we can do by typing it in. Curl HTTP 10.10.169.1/cookie test. Not logged in. Wonderful. We can see that a return message of not logged in. Now we'll send another request with the logged in set to true and the admin cookie set to false. Cookie test. So we need to go back up and set a header value of tag h cookie to logged in equal to true, and it wants us to set admin equal to false right now. So that's what we'll do. And now we are a logged in user. So now we can do it in set. Oh, where's my, give me that back. Yeah, okay. Set admin equal to true. I imagine it'll say logged in as admin. True. True. Nope, logged in as a user. Is that because I... Login true, admin true. Move down. Okay, yeah, that's what it was. Cookie tampering. We'll scroll down. And back up. I don't know why it's like splitting like that. It's freaking weird. Let's see. The return logged in as admin, as well as the flag, which you can now use to answer one of the questions, hashing. Sometimes cookie values can look like a long stream of random characters. These are called hashes, which are an irreversible representation of the original text. Here are some examples that you may come across. MD5, SHA-256, SHA-512, and then SHA-1. We'll pop that into CrackStation. You can see in the above table that the hash output from the same input string can significantly differ depending on the hash method in use. Even though the hash is irreversible, the same output is produced every time, which is helpful for us as services such as CrackStation.net keep databases of billions of hashes and their original strings. Encoding is similar to hashing in that it creates what would seem to be like a random string of text, but in fact the encoding is reversible. So it begs the question, what is the point of encoding? Encoding allows us to convert binary data into human readable text. That could be easily and safely transmitted over mediums. Only support plain text ASCII characters. So really it's the whole obfuscation or like security through obscurity. That's what they call it. But basically the point is that that's not really like a great way to go about it. It's probably going to have us do this anyway. Dang it. But we want to not do any of those things. We want to echo what we're going to give us to base 64 tac D. And they're not giving us this, but I just want to see it. Did it store here? It did not. Stop storing crap I don't want. Right. So now that we know the format of this, what we could do is be like, we could copy it and say, like something like this to what, base 64, I think that's how that's gonna work. We'll just change it to admin equals true. Yo, break's coming up. If you don't want to watch it on Twitch, head over to YouTube. See you there. What did I miss? I missed a quotation, or I missed a quotation mark, so that's not gonna run. There we go. Right. Yeah. Okay, cool. That's right. So now we could like potentially set this as our session cookie. And because we've changed it from false to true, it could give us administrator. What is the base 64 encoding of this value? Which we will do here. So echo this to base 64 tac D. Not base 64, but base. Tryhackme. Base 64. Encoding. Thank you. What is the value of this MD5 hash? So we'll take this MD5 hash, we'll take it over to CrackStation. Paste it in there, confirm that we are not in fact a robot, and crack hashes. So it responds with a password, whatever. It responds with this password. What was the password? 463729. Thank you. Encode the following value. Okay, so we actually already did that, which is something it wanted us to do at some point. So we'll copy this. See the clipboard. We should have it in our clipboard, and we do, and then we'll just submit that. Cool. All right, indirect object reference is next. Give me just a minute. Everybody, go ahead and take a break if you haven't already. And I'll be right back. All right, and we're back. Nice little bitty break there. Okay. Let's see what's next. We're going to be looking at idors. Idors. Learn how to find and export idor vulnerabilities in a web application, giving you access to data that you shouldn't have. Here we're going to practice exploiting real case scenario, idor in real case scenario. Idor stands for indirect object reference. Yes, we know that. And is a type of access control vulnerability. This type of vulnerability, which we can look that up. OWASP top 10. This is pretty outdated. It was made back in 2021. 2017, remade in 2021. They're supposed to make another one sometime in 2024 is my understanding. Or maybe it was 2025. I don't know. I just heard somebody say that. What did they say? They called it access control vulnerability. So right here, we can see that AO1 2021 broken access control. See there, top of the list. What does idor stand for? Indirect object. Oh. Insecure direct object reference. Insecure direct object reference. What was I saying? Indirect object reference. Insecure direct object reference. Excellent. Let's have them show us an idor example. Oh, okay. Order number should be 1, 2, 3, 4. And then we can actually see it order 1, 2, 3, 4 invoice. So we could just take this parameter 1, 2, 3, 4 and fuzz it, which I assume is, I don't know, they probably did that somewhere. We'll do that next. No, don't do whatever that did. Don't do that. Copy it. Give me the sidebar. Oh, I need to be over here. Curiosity gets a better view when you try changing the user ID value to 1000 instead of... Oh. Okay. HTTP online service.thm online secvice profile user ID equal to 1000. Would help if I spelled profile properly. What else would help? We're having trouble finding that site. Service.thm online view service.thm. What is the flag of from the idor example website? What? You cannot view this level yet. Check the emails below. Trying to identify URL that looks like it could be potentially vulnerable to idor. Oh. And receive a flag by discovering. Okay. I mean, we know what's vulnerable. Are you telling me I can edit it here? I should edit it here? What do you want me to look at? Like 0? 1? What do you want me to look at? Oh, 1000. Okay. Gotcha. Oh, okay. Tryhackme. Idor. Vuln found. Nice. Finding idors in encoded data. Encoded IDs. When passing data from page to page, either by post data query strings or cookies, web developers will often first take the raw data and encode it. Encoding ensures that the receiving web server will be able to understand the contents. Encoding changes binary data into an ASCII string, commonly using the lowercase a to z, uppercase a to z, 0 to 9, and equals character for padding. The most common encoding technique on the web is base64 encoding and can usually be pretty easy to spot. You can use websites like base64decode.org to decode the string, then edit the data and re-encode it with base64, which we don't need 2 of these. And then resubmit the web request to see if there's a change in the response. See the image below. So it's hard to see, but we can see it's encoded. We're going to decode it. That returns ID of 30. We're going to tamper with that, set it to ID of 10. We're going to re-encode it. The letter changes. We could see that Z became capital T. They're going to submit that, and we get skull and crossbones. What is the common type of encoding used on the web? Base64. They set it up above. Hash IDs. Hash IDs are a little bit more complicated to deal with than encoded ones, but they may follow a predictable pattern, such as being the hash version of the integer value. For example, the ID number 123 would become the string in MD5 if MD5 hashing were in use. It's worthless putting any discovered hashes through a web service like this. CrackStation, which has a database of billions of hashes, to see with messages what is the common MD5. Yep. Finding idors in unpredictable IDs. Or idors between 2 accounts. Between accounts, 2. Where are idors located? The vulnerable endpoint you're targeting may not always be something you see in the address bar. It could be content your browser loads in via an AJAX request or something that you find referenced in a JavaScript file. Sometimes endpoints could have an unreferenced parameter that may have been of some use during development and got pushed to production. For example, you may notice a call to user details displaying your user information authenticated through your session. But through an attack known as parameter mining, you discover a parameter called user ID that you can use to display other users' information. For example, user details parameter user ID equal to 123. Okay. We'll start this machine and see what happens. As it starts, move back over to the attack box. First, you'll need to log in to do this. Check on the customers section and create an account. Once logged in, click on your account tab. Your user account section gives you the ability to change your information such as username, email, password. You'll notice the username and email field pre-filled in with your information. We'll start by investigating how this information gets pre-filled. If you open your browser, developer tools, select the network tab and then refresh, you'll see a call to an endpoint with the path API v1 customer ID, user ID. This page returns in JSON format, your user ID, username, and email. We can see from the path that the user information shown is taken from the query string. Okay. ID. Username admin, email admin@test.com. What is the username for user ID of 1? This admin add. Jeez. Oh, I should maybe not do that. Alt.c. Password. Account already exists. We'll try this. Your account, inspect, network, start over. Customer ID of 15. What we can do is get Burp Suite and just capture this. What does it tell us to do though? You can try testing this ID parameter for idor and try and select IDs. Selecting users with IDs 1 and 3. Okay. Proxy, intercept on, burps on, send the request, burp, forward this, forward that. We'll send this to repeater. And also we'll just set it to 1 for fun. And let this bring best back. Cool. So now we can see Atom 84. Atom 84 and then repeater. It wanted 3, right? 3 is John 911. Atom 84 and John 911. Okay. Let's turn burp off. Or yeah, intercept off. What was it? Shit. John 91. Right? No. What was it? Adams 84. Adams 84. Adam 84. What is the email address for user ID 3? Which we have in repeater of fakeemail.tryhackme. J@fakeemail.tryhackme. fake email.tryhackme. Cool. That's idor for you. Next room, file inclusion. Okay. I'm actually going to close out the attack box. Oh, wait, attack box. What is file inclusion? Actually, how much more do we have left? Hey, we got an ad in 1 minute. You want to keep watching, move over to YouTube. Is that all we have? These two left? I thought there was quite a bit more. Yeah, there is. We've only made it halfway through. It's getting into some really good stuff though. The room aims to equip you with the essential knowledge to exploit file inclusion vulnerabilities, including local file inclusion and remote file inclusion and directory traversal. Also, we will discuss the risks of these vulnerabilities and if they're found and the required remediation. We provide 10 seconds. We provide some practical examples of each vulnerability, as well as hands-on challenges. In some scenarios, web applications are written to request access to files on a given system, including images, static text, and so on via parameters. Parameters are query parameter strings attached to the URL that can be used to retrieve data or perform actions based on user input. The following diagram breaks down the essential part of a URL: protocol, domain name, the file name, the query string begins, the file parameter, or the parameter, and then whatever you're looking for. For example, parameters are used with Google search, where GET requests pass user input into the search engine. Google search, Q, Tryhackme. If you're not familiar with the topic, you can view How the Web Works module to understand the concept. Let's discuss a scenario where a user requests to access files from a web server. First, the user sends an HTTP request to the web server that includes a file to display. For example, if a user wants to access and display their file, their CV from the web application, the request may look something like webapp.tryhackme get file user cv.pdf, where file is a parameter and user cv.pdf is a required file to access. Right, so here's just showing us like the directory, this web server, how it's built. We can see the CVs, www, and app folder inside of CVs. When you upload a file, it goes into the CVs directory. Inside of app, the GET request is sent to app. CV is sent to CVs. File inclusion vulnerabilities are commonly found and exploited in various programming languages for web applications such as PHP that are poorly written and implemented. The main issue of these vulnerabilities is the input validation, in which the user inputs are not sanitized or validated and the user controls them. When the input is not validated, the user can pass any input to the function causing the vulnerability. What is the risk of file inclusion? By default, an attacker can leverage file inclusion vulnerabilities to leak data such as code, credentials, or other important files related to the web application or operating system. Moreover, if the attacker can write files to the server by any other means, file inclusion must be used in tandem to gain remote command execution. Got it. Start the slab. Deploy the attached VM, follow and apply the technique as well to the challenges in order to access the. My bet is that I've got machines open still. Not that one. Goodbye. Goodbye. There we go. Here are the labs that available file inclusion. Once you've VM deployed, please wait a few minutes for the web server to start, then progress to the site. Is it like forcing us? It is not forcing us to use the attack box, is it? Or okay, cool. So it's giving us the option. The attack box is fine. It's fine. Fine. It's fine. It's fine. Let's check this out. Uh-huh. It should look like that, but it does not look like that. Oh, I need to wait on it to spin up. That's right. It started, but whatever it's running in hasn't started yet. I'll give it another minute. Oh, have some water. Get a drink of water. Drink, drink, drink. Let's try now. Yeah. So lab 1 include okay. So local file inclusion. Patch reversal, also known as directory traversal, a web security vulnerability allows an attacker to read operating system resources such as local files on the server running an application. The what? There we go. The attacker exploits this vulnerability by manipulating and abusing the web application URL to locate and access files or directories stored outside the application's root directory. So they're telling us we're in var www.html. So we only need to go back 1, 2, 3, right? Etsy hosts. Yeah. Etsy password. IRCD. Ben Shell. Why do they all have? and bash. Okay. Path traversal vulnerabilities occur when the user's input is passed to a function such as file, get, contents, and PHP. It's important to note that the function is not the main contributor to the vulnerability. Often poor input validation or filtering is the cause of the vulnerability in PHP. You can use the file get contents to read the content of a file. You can find more information about this here, which is what? PHP. Okay. It's their manual. The happy path would be the user requesting the contents of user CV PDF from a defined path var www app CVs. We can test out the URL parameter by adding payloads to see how the web application behaves. Path traversal attacks, also known as // attack, take advantage of moving directory one step at a time using the double dots. File equals, then attacker may send. Yep. Suppose input validation. Each dot entry moves one directory up until it reaches the directory root / then it changes the directory to etsy, and then it reads the PJWT file. So in the diagram, you see we're going up. So we're going from CV. Actually, this is going up 4, but we're only going up from app var and then into here, and then we're moving into etsy, and then we're reading the PJWT file. And that's what's happening here in lab 1. That's why we can view this information. Look, we went up 1, 2, 3 into etsy, and then PJWT, because it's sending a get request, right, to the PJWT file. Similarly, if the web application runs on Windows, the attacker needs to provide Windows paths. For example, if the attacker wants to read the boot ini file located in C boot.ini, then the attacker can try the following depending on the target OS version. Well, so we're going now 4 directories or Windows win.ini. This is decent. Same concept applies to Linux operating system, where we climb up directories until we reach the root directory, which is usually C /. What? Nah. Deck. Desktop. There we go. Sometimes developers will add filters to limit access to only certain folders or directories. Below are some common OS files that you could use for testing. Right, so these are pretty nice. These are decent. Might even be worth like adding these as like something to look at for LFI, which hopefully I have somewhere. Should have another bit of it somewhere. Server-side template injections, XML, XXE. Where would LFI be here? I'll upload. Probably should have separated this better. Here we go. Okay, we'll give ourselves a little space. Didn't quite work. And I think that overall, I'm not really concerned with I just want the files. I'm not super concerned with like what they're doing. I just want stuff that I can read. That would be crazy if we can read bash history or root history. Out of here. No. Cool. What function causes path traversal vulnerabilities in PHP? Where's the GET request? File get contents. Here we go with LFI. LFI attacks against web applications are often due to developers' lack of security awareness, with PHP using functions such as include, require, include once, require once, often contribute to vulnerable web applications. In this room, we'll be picking up PHP, but it's worth noting LFI vulnerabilities also occur when using other languages such as ASP, JSP, or even Node.js apps. LFI exploits follow the same concepts as both as path traversal. In this section, we will walk you through LFI scenarios and how to exploit them. Suppose a web application provides two languages and the user can select between EN and AR. The code above uses the get parameter, get request via the URL parameter lang to include the file of the page. Right. Load the page, Arabic, English. Where that and that file exists up there in the same directory. Theoretically, we can access and display any readable file on the server if there isn't any input validation. Let's say we want to read Etsy password file, which contains sensitive information about the user's Linux operating system. File equals Etsy password. In this case, it works because there isn't a directory specified in the include function. Right. Such as this include languages, get lang. Next in the code, the loader decided to specify the directory inside of the function. So lang equals, and now you have to back out of the languages. What was the request? What would the request URI be? Give lab 1 and try to read Etsy pass. Okay. Just saying I just read it like that. Is it wanting this whole thing? Stop it. I think it wants lab 1. I think it wants the entire thing. Is it wanting the encoding? It's not. Like that? Yeah, okay. What is the directory specified in the include function? So we'll go back to lab 2. This, so all we did, and I mean, we just made it like throw an error, but, and they're showing us errors. I guess that's what they're wanting. What in lab 2, what is the directory specified in the include function? Oh. Just includes? So what, like if I put that in That's not what I meant to do either. Give me a break. That's not gonna work either. Oh, it is gonna work. Yeah, returning the. Oh man, it's just gonna keep going because it's just including itself over and over and over. Really? Oh, let's hop off that. How many of these are there? A few more. In this task, we go a little deeper into LFI. We discuss a couple of techniques to bypass filters with the included function, check code, web app, exploit. However, in this code case, we are performing black box testing, in which we don't have access to the source code. In this case, errors are significant in understanding how the data is passed and processed in the web app. In this scenario, we have the following entry point. No, don't do that to me. If we enter an invalid input such as THM, we get the following error. Laying thm.php file to OpenStream, we just languages that fail to OpenStream. No such file directory in var www.html thm for on line 12. So, oops. So in this file or in this directory, there's no file called thm.php. Languages, yeah, okay. You will fail to open. So it's like, right? It's putting .php on the end of everything. So they're saying function reads inputs. They're saying send a null byte. Bypass the scenario, we can use the null byte value, which is %00, and that's what they're doing here. No, the null byte trick is fixed and working in PHP 5.3.4 and above. So this is an old vulnerability, but that doesn't necessarily mean it doesn't still exist, right? So if we're doing testing, we need to make sure that we still test for this if we can determine the version of PHP. In the section, developer decided to filter keys to avoid disclosing sensitive information. The exploit will be similar to this. We can also try this to make it clearer. If we try this concept in the following, concept in the file system using cd, it will get you back one step. However, if you do cd dot, it stays in the current directory. Similar, if we try etsy password, it results in etsy, yeah. And that's because we moved up one root directory. Now, if we try etsy password here, it's going to result in etsy password since dot reference to the current directory, yes. So what this is doing is it's filtering on, just from the look, it's filtering on this. So it's removing this, and what they're doing is saying that it's going to filter this out, and then the only thing that's going to be left is another set, right? So these are going to be filtered out. The only thing that's going to be left are the period and the slash. So .. remove this, .. remove this, .. remove this, .. so on and so forth. So what they've done is they've set filtering up for this .. but what they need to do is set it up to do it recursively, so it'll keep doing it until there are no more .. or whatever available. Give lab3 a try and try to read this, see what it looks like. Oh shit, I closed it out. Damn it. Well, it should just show up now, right? 10, yeah, 9111. What was it, lab 3? So we can expect this to not work. Yeah, because it's doing that. I do not think that this is going to work here. Right, because now it's not reading this as a null byte, it's reading it as a string. Let's try this though. Etsy pass WD dot slash dot slash dot slash dot slash Etsy pass WD that bar. It's still giving us, okay, includes this %00, which honestly, try this. Okay. So this is what we need. One, two, three, four, yeah. What function is causing the directory traversal in lab 4? Function dot file hello? Function dot file tag get dash contents. Without that. What function is causing the directory traversal in lab? File get contents? File get, oh. Underscores. File get content, not file get content. Contents. Try out lab 6 and check what is the directory that has to be in the input field. Lab 6. Nice to add allowed files at this folder only. THM-profile. Okay. Try out lab 6 and check what the directory output is. Try to read. So what we can do maybe is set it to var. This is probably way too much, but THM profile. One, two, three, four. 1, 2, 3, 4, 5, whatever. Cool. So that worked. So because we included THM profile in the request, and then we went all the way back to root Etsy, we could read os-release. And what was the question? What's the version ID? 1204. Yeah. It's down here at the end. I mean, you can see it in other places, but 1204. And we'll move on to remote file inclusion. Remote file inclusion is a technique to include remote files into a vulnerable remote files into a vulnerable application. Like LFI, the RFI occurs when improperly sanitized user input allows an attacker to inject an external URL into an include function. One requirement for RFI is that the allow URL fopen option needs to be on. The risk of RFI is higher than LFI since RFI vulnerabilities allow an attacker to gain remote code execution on the server. Other consequences of a successful RFI attack include sensitive information disclosure, cross-site scripting, and denial of service. What is it? Allow URL fopen? That's probably going to be a question, so we'll snag it while we're up here. An external server must communicate with the application server for a successful RFI attack. When the attacker hosts malicious files on their server, the malicious file is injected into the input function via HTTP request, and the content of the malicious file executes on the vulnerable. Here, it's about to start. Yeah. So we can see here they're saying the file lives at attacker.tryhackme command.txt. So it's getting that, it's going, sending the request. It's actually then the web server sending the request to the attacker's content. This is just telling it to print out hello Tryhackme. RFI steps. The following figure is an example of steps for successful RFI attack. Let's say that the attacker hosts a PHP file on the server where seam.txt contains a printing message, hello GHM. Yep. First, the attacker injects the malicious URL, which points to the attacker server. If there's no input validation, then the malicious URL passes into the included function. Next, the web app server will send a GET request to the malicious server. Yep. Visit this place. Why you do this? Why can't you just work? Sure. So file equals. What do we even have here? We'll pop this in. PHP echo, yeah. And then we'll, it's not that I actually need Python http.server on port 80. Yeah. And what did I call it? Test.php. Yeah, look at that. There we go. And we can actually see the GET request here. For test.php, I got a 200 success, returned 200 success, and it came in from 10.10.90.111. Cool. Remediation. Capture flag 1, anti flag 1. I'll just read it. I think it's wanting us to go, no? Challenges. Yeah. Index test.php. Challenge 1. Find an entry point that could be via get post cookie. Enter a valid input to see how the web server behaves. Enter invalid input, including special characters and common files. Don't always trust what you supply in input forms is what you intended. Use either a browser address bar or tools such as Burp Suite. Look for errors while entering invalid input to disclose the current path of the web application. If there are no errors, then trial and error might be your best option. Do I have to do that? Playground. Could I do something like this instead? That work? Your browser sent a request that the server could not understand. 1, 2, 3. What's it wanting? What is the output? And I assume that that's because it's like trying to run that. And what we need is for it to like put the contents, like show us the contents. Okay, so let's do it again. We're just nano. Pop it in. Yikes. Not what I meant. Midis. And let's just see if this works. I probably don't have to do this. Like, this is probably enough. I would think. We'll find out. 10, 6, 48, 143, test.php. We have to. That's definitely not going to work. Python. Yeah, there we go. Okay, cool. 5 VM Tryhackme this. So there's that. We would get that. So if you don't understand what happened, what we did was we created a file. We use this. So set a variable. We set it to file get contents. And then we changed that to Etsy hostname. And then we made it print Etsy hostname, the output of hostname. To the web page. Yep, and that's where we get the content here. And then here's our request that we made. The input is form is broken. You need to send post requests with file parameter. So I think that we're good there. What just, oh man. Okay, close those out. I think we're done with the playground. We'll capture the flag of Etsy flag 1. See what happens. And it's kind of saying, it's saying something like maybe you want to use Burp Suite or edit in the browser. Burp Suite might be easier. Maybe. We'll see. Test. Files test, and then, oh. Gotta turn the proxy on. There it is. No, that's not it. Testing. There we go. It probably like had cached that. And let's turn intercept off. Cool. The input is broken. You need to send post. Okay, well, let's just change request method. And render the page. Failed to open stream. No such file in this location. What? Oh, wait, it wants us to get something specific. Etsy flag 1. Okay. Etsy flag 1. There we go. Let's go back to pretty. And we'll grab our flag. So it wanted a post request. When we put it up here to get, we needed to send a post, and then it returned with our flag value. And challenge 2. Do I still have is intruder on? It's not, or intercept. Oh shit. What do I do? Yeah, accidentally turned it off. Will this put you back? It will. Okay, cool. All right, so let's go back to challenge 2. Refresh the page again. Only admins can access this page. Okay. Let's try this. Send the request. Cookie equals guest. Cookie equals admin. Welcome, admin. This is an admin webpage. What? Admin. Repeater. Just go ahead and forward it. Wait, what? Slightly confused. chow2.php. Send it. Oh. Challenges chow2.php. chall2.php. Why are you not sending? Why are you not responding? Let's turn you off. Change this to admin. Now every time we refresh, we should get this page. Include a file in the input form below. I don't see an input form below, but thanks for suggesting I do so. What, like something? I don't know. I don't know. Let's do some. Should I be seeing something? File content preview of admin. Wait, what? Is it saying that? Is that the cookie? It is. Whatever. Etsy flag 2. Flag2.php. We need a null byte. We're gonna send this to repeater. Get out of here. Get out of here. Test.php. Cool. What is it? %00. Yeah. Cookie is yummy. Oh man. Okay. So there's our second flag. Maybe if it'll take it. Hello, take it. Oh, right. Turn intercept off. There we go. Yes. All those requests all coming through at once. Okay. Challenge 3. Challenge 3. No such file. No, okay, so it's actually removing it this time. So we'll do another dot dot slash in place of everything. Yeah, dot dot slash. Right? Dot dot slash dot dot. Okay. Maybe that's right. Yeah, here. We're still seeing it's removing. Well, you removed that. And it's okay. So what? Like this, and then I don't know. We'll give that a shot. Can I like get the contents of anything? Let's see if it changes. Okay, so it is changing. This. No, it's just that. And it only return that. Challenge 5.3. Failing to open this. Right. Well, it's not even like I want. Oh. What's happening there? Oh, what? Wait. Challenges slash. Could it be like var dub HTML chow 3.php slash like that? Is that something? Is that a thing? Okay. No. It's actually removing the slashes out of there. And it didn't read those values. Okay, here's what we'll do. Send this to burp repeater. Here's our weird ass cookie admin for whatever reason. Nothing happens. Admin. Yes. Okay. Test. If that doesn't work, it's highly unlikely that this would work, right? It's only reading. I don't know. Still seeing that. It's actually removing it. How much does it remove it? Eternally? It does appear to be recursive. Go to OpenStream function.include for inclusion. Challenge 5. That's working. Oh, whoa. File contents. Okay. Was it actually that easy? No. No, it was not. Current path for www.html etsy pass. Oh, etsy flag 3. Should include etsy photo stream. It does see it, right? Our etsy flag include failed opening for inclusion. And what about just flag 3? Oh, okay. Okay. Yeah. Okay. What I didn't see is that it was appending.php after I made the request. Yeah, that's what the problem was. Copy. I need to turn proxy off. There we go. Cool. Let's terminate the machine. Oh man. I didn't realize that wait, what? No, I didn't skip it. What happened? Did I just not accept it? What's going on here? Show me everything. I don't understand why it acted like I didn't complete it, and I guess the answer is I didn't hit complete on this one. As a developer, it's important to be aware of web app vulnerabilities, how to find them, prevention methods, and prevention for the file inclusion vulnerabilities. Some suggestions include these, which I'm going to actually copy and pop in here. And we will do numbers. Prevention methods, LFI, RFI. Right? Remediation. Okay. Keep system and services, including web app frameworks, updated with the latest version. Turn off PHP errors to avoid leaking the path of the application and other potentially revealing information. A web application firewall is a good option to help mitigate web app attacks. Disable some PHP features that cause file inclusion vulnerabilities in your web app if your web app doesn't need them, such as allow URL if open on and allow URL include. Carefully analyze the web application and allow only protocols and PHP wrappers that are in need. Never trust user input. Make sure to implement proper input validation against file inclusion. Implement whitelisting for files, locations, as well as blacklisting. All right. Ooh, we are moving. Okay. Even though I answered them, I will read through this. In this room, you'll learn what an SSRF is, what kind of impact they might have. You'll view some example SSRF attacks, how you can discover SSRF vulnerabilities, how to circumvent input rules, and then we have a practice for you to practice against to try your newfound skills. SSRF stands for server-side request forgery. It's a vulnerability that allows a malicious user to cause a web server to make an additional or edited HTTP request to the request of the attacker's choosing. There are two types of SSRF vulnerability. The first is a regular SSRF, where data is returned to the attacker's screen. The second is a blind SSRF vulnerability, where an SSRF occurs, but no information is returned to the attacker's screen. What's the impact? A successful SSRF attack can result in any of the following: access to unauthorized areas, access to customer organizational data, ability to scale to internal networks, reveal authentication tokens or credentials. Click the view button, which will take you through some common SSRF examples, how to exploit them, and even a simulation to see if you can take advantage of an SSRF vulnerability using what you've learned. We're going to take you through some examples as far as attacks and explain how they work. At the end of the examples, you have to figure that one out for yourself. The expected request is what the website server is expecting to receive, with the section in red, the URL of the website will fetch for the information the attacker can modify the area in red. This API stock item ID. So hacker requests HTTP API website.tryhackme API user HTTP API website requests this. API server returns user data to the website instead of stock information. Website returns user data to the hacker. So we don't have privilege to access API but website.thm has the ability to access it. It could also be like something internal, right? So we just don't have access to it. Anyway, the point is we make the request to the server makes a request to the API sends the response to the server sends the response back to us. The below example shows how an attacker can still reach the API user page with only having control over the path by utilizing directory traversal. When website receives .. which I don't see, this is a message to move up a directory, which removes the stock portion of the request. Okay. In terms of final request into API users. Okay. Expected request. the hacker request. URL equals dot slash user. Sends that to the server. That goes server requests API stock user. Okay. The attacker can control the server's subdomain to which the request is made. Take note of the payload ending in and x equals. It's an empty value being used to stop the remaining path from being appended to the end of the attacker's URL, and instead turns it into a parameter x equals in the string in the query string. So we're requesting stock server equals user x equals, and then we're just cutting it off and saying and ID is equal to 1, 2, 3. And what this actually says is api.website.tryhackme user where x is this, then ID of 1, 2, 3. User, oh, is it just saying, it's just saying that like that stops it, right? Actually, I don't know. We'll find out. Going back to the original request, the attacker can instead force the web server to request a server of the attacker's choice. By doing so, we can capture request headers that are sent to the attacker's specified domain. These headers could contain authentication credentials or API keys sent by website.thm that would normally authenticate to API website THM. I won't lie, I thought this was going to all be very, very fast. So I will likely be splitting this up or completing the rest offline. I did not know that it was going to take this long. But it makes sense. I mean, you can't rush it, right? And you don't want to rush it. So the expected result is URL equals API stock item ID 1, 2, 3. But instead, we're going to put in hacker domain. So our location, website request data from, instead of api.website.thm, revealing the API key. This is what you've learned. Changing the address and the browser below to force a web server to return data from here to make things easier at the bottom of the mock. Okay, well, I mean, is it not just that? Mm-mm. go back, take a look. Is it just, it's not just that. Otherwise it would be working. HTTP, okay. Server were now request, okay. Server equals server dot website dot thm. Slash API slash. Make it easier to search because the mock browser will show the URL that website shares. Okay. And okay. So basically I needed it to just like stop. I needed it to stop. That's what my problem was. I was like, okay, well you definitely need to do this. And then what? And then remove it. I was like, how do I get rid of this junk? And it's just adding the ampersand. So let's check this out. Finding an SSRF. Potential SSRF vulnerabilities can be spotted in a web application in many different ways. Here's an example of 4 common places to look. When a full URL is used. When a full URL is used in a parameter in the address bar. Right? A hidden field in a form. A partial URL as just the host name, or perhaps a path, destination equals URL forms contacts. What website can be used to catch HTTP requests from a server? Are they giving us one? Oh. I told monitor requests such as requestsbin.com. Requestbin.com. Can we check this out? Create request bin. Ooh, no. I'm not signing up for you. There's also, it's not that. There's something else. SQL XXS SSTI. Where is that? Webhook.sites. Yeah. So let's go to webhook.sites. What? Is it, what's the problem here? Yeah. Yeah. Anyway, I'm gonna hop off here. Yeah, everyone, I'll finish this later.